we will do magnetic force on a current carrying conductor. So first of all, if we consider a charged particle Q is kept in a magnetic field B. So how much force it will experience? F is equal to Q V cross B. This is the basic formula that we know about force on a charged particle due to magnetic field, where F is the force, magnetic force I should say, where Q is the charge on a charged particle. And what is V? V has to be the speed of the particle. So the particle will experience magnetic force only when there is some speed. Okay, it has to have some speed. So this is speed of particle. And next point is B. What is B here? B is the external magnetic field. Okay, external magnetic field. Some students think that this is the particle moving. If it is a positive particle moving, it will also create its magnetic field. Correct? So this is B? No. Here the field that this particle will create, we are ignoring. We are just thinking that this is a charged particle in the magnetic field moving. It will experience a magnetic force. This is called QV cross B. Okay, so remember B is not the field produced by the particle. B is the external field in which we have kept this particle. But today we are deriving, using this formula, we will derive what will be the magnetic force experienced by a current carrying conductor. Means instead of a single particle, we have kept a wire in the magnetic field. So this is the magnetic field B, which is external magnetic field. This is external, and this is the wire which is kept. And this wire, suppose, has some current which is flowing in the wire. Okay, the length of the wire is L. Okay, and there is some current flowing in the wire. Means maybe this wire is connected to some cell which is not shown in the diagram for the simplicity of the diagram. Okay, this something like this is connected to a cell, and this wire kept in the field. Okay, now the cross sectional of area of wire is A, and L is the length of wire. And what is the A? This is the cross section area. So what will be the volume? The volume of wire will be A into L, base area into length of the wire. Okay. Suppose L is the density, charge density means number of electrons per unit volume. This is the charge density. This is also known as charge density of the wire. This is showing how many number of electrons are there in the wire. So that means total electrons will be how much? Total number of electrons will be charge density into volume, correct? Because n is the number of particles per unit volume. So n into V. So n into, and what is V? V is A into L. So these are the total number of particles. So how much will be the total charge? If number of particles are this much, so total charge available, total charge particles is this. So what will be the total charge? Total charge will be NaL into charge of one electron, because the charge of one electron is this. Correct? So this is the total amount of charge present inside this wire. So how much will be the total force experienced? See, the force experienced by a single charge is this. So by these many number of charge, total force F net will be how much? Total number of particles NaL into E, right? This is showing the part Q. In this formula we need Q, V and B. So this is showing total charge is NaLe into V cross B. And what is B? V is the particle of the velocity of the particles in the wire, which is nothing but the drift velocity. So let me call it Vd. Okay, the drift velocity of particles. So now we will just rearrange it little bit. Let me show you how. Can I do just L here and Vd here? We are just replacing to N, A, L. Instead of L, I am writing here V. So I have done just rearrangement of these quantities. So I have N here, N here, A is here, L is here, yes, L is here. I am just writing instead of Vd here. Vd, yes, and E is here. The charge, yes, everything is here. I hope you understood what I am saying. And B is at its place. So I have done just the rearrangement of these letters here. If you observe, all the letters have been rearranged here. If you have studied in the last derivation, we know the current in the wire is NEAVD. This is the current formula in the wire. So where I is, let me write down, is current. Okay. N is the charge density. We already did. E is the charge on the electron, 1.6 10 to the minus 90 coulomb. A is the cross-sectional area of the wire here. If wire has some thickness, so this is the cross-sectional area. Vd is the drift velocity. So by using this formula, can I say this is nothing but I, the current of the wire? So let me write down force. Net magnetic force experienced by the wire will be I into L cross B. This is the net force experienced by the wire kept in a magnetic field. Suppose this is the wire, current flowing is I, okay? The length of the wire is L. Then it can also be written as F is equal to ILB sine theta. And what is theta here? Theta is the angle between the magnetic field B and the length of the wire. This is the wire. So this is theta. This is the angle theta. Okay. So I hope you got it. See you in next video. Bye everyone.